Very good afternoon, students. Welcome to prestigious IIT and NEET Foundation or Focus C program by Kinematics Talent Schools and Mastermind Schools. So I welcome all the class 8 students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 8th. Our ongoing chapter Kinematics, the second chapter, and today we are entering into the session number 4. Means so far we completed 3 classes in understanding the basic concept of kinematics, which is totally deals about the motion of a body. So study about the motion of the body without knowing about cause. We are not discussing the cause here. We are discussing only about the motion. So whenever body is in motion, we'll come across various terminology and we discuss about the various terms like distance, displacement, speed, velocity, acceleration, retardation. Then we have seen the relationship between these all the terms which are come across during the motion of a body, right? So we'll continue where we stopped in the last class. But before that, let us review what we learned till now in the last 3 sessions in one screen. You can see on the screen. So there are different types of motions are there. And what we learn, you can see, we learn about the main branch of kinematics, that is about mechanics. Then we enter into the kinematics. Then we learn about vectors and scalars, difference, how these physical quantities are classified based on the magnitude and direction. Then distance and displacement, the very important terms when the body is in motion. Then speed and velocity, we have seen the differences. Then acceleration and retardation. These are the terms which will come across during the motion of a body, right? So we'll further continue, and already we are introduced about the even equations of motion also that we'll see today. So this is the differences here, clearly you can see. So based on the parameter, the main parameter is magnitude, direction. All the physical quantities, whether they may be fundamental physical quantities or derived physical quantities, having only magnitude, like mass, length, and time, they are placed under scalar quantities, scalar physical quantities. Others, those who are having both magnitude and direction, they are placed under vector physical quantities, right? For scalars, we'll deal only with the pure algebra in mathematics also, whereas vectors having separate algebra called vector algebra. We can use all the 4 mathematical operations between the scalars as well as vectors also. Means you can add the vectors, subtract, multiply, divide also. The resultant depends mainly on magnitude in case of scalars. In case of vectors, depends on both magnitude and direction. Okay. Clear? This is about the very important classification. Then we discuss about the terms which will come across during the motion of a body. When a body is in motion, it's moving, it's changing its position with respect to surroundings or time. They cover some distance or they'll go for displacement. So these are the twin words which sound same. In our daily life, there is no difference between distance and displacement. But in physics, there is a huge difference is there. The difference you have seen here, you can see on the screen. Right? See, you can see the total length of the path traveled by a body is called distance. Whereas the shortest distance is called displacement. The shortest distance between initial position to final position. Okay. So as distance does not have any direction, it is a scalar quantity. Displacement is a vector quantity. Distance is always positive because it does not have any direction. Whereas displacement can be either positive or negative or even zero also. Right? When a body starts from one position and goes to another position, all the individual algebraic sum of the distances added to get the total distance. Right? When there is a motion is there, definitely there is a distance covered. But displacement can be zero even though there is a motion. When a body comes back to original position. Simple example I say. Suppose you are started here. We are starting from your home here. Right? It is our home. We went to market. Market. That is around 2 kilometers. Right? What you observed is market is closed due to some XYZ reason. So you came back. Again, same 2 kilometers. You came back to your home. So in this case, so what is the total length covered from 2 kilometers and 2 kilometers, both? Right? So distance is 2 kilometers plus 2 kilometers is 4 kilometers. That is distance. But what about displacement? Because initial position and final position are same. Initial position and final position are same. And direction is opposite. 2 minus 2 will get. Distance is sum of the algebraic sum from here to here, again here to here. 4 we got. But in case of displacement is 2 minus 2, that is 0. Because you came back to original position, initial position. Right? That's it. That is the possibility that either displacement can be positive, negative, or even 0. When you come back to your initial position, the displacement becomes 0. Right? Either it is a distance or displacement, both we measure in either in meters or in centimeters only standard. Of course, there are many higher units are there. Okay. Of course, we have seen about even distance, speed, and velocity also in last class. So clearly, it is also same as the speed is depends on distance covered, velocity depends on displacement. So the same way we can study the distance and displacement, right? How we are studying distance the same way can consider same. One is the scalar quantity, other is the vector quantity. In when you come to a part of speed, generally speed is measured in speed or velocity kilometer per hour. Like the black, I'm writing on black. Okay, write in kilometer per hour speed. Correct. Generally, when you see any vehicle, there are two types of meters will be there. One is speedometer. Other one is odometer. Whether 2-wheeler or 4-wheeler, we can find these two. Speedometer will show how much speed you are going. That is how many kilometers per hour you are traveling. Right? 50, 60, 70, 80, 100, 200. Right? Odometer will show how much distance you are traveling. How many kilometers you traveled. How much speed you are going. Right? So generally, the speed is measured in terms of kilometer per hour. Or velocity also. Then what is kilometer per hour? If you convert them into simple way, kilometer, kilometer is nothing but 1000 meters. You can write. By hour you can convert into seconds. That is 3600 seconds because 60 into 60. So we can cancel out the 2 zeros and 2 zeros here. 2 5s are 10. 2 18s are 36. That is 5 by 18 meter per second. 1 kilometer per hour is equal to 5 by 18 meter per second. It's a very important conversion in solving so many problems related to speed or average speed. Right? Means 1 kilometer per hour is equal to, if you want to convert, for example, if you want to convert 20 kilometer per hour is given, is equal to dash meter per second is asked. Simply you can write 20 into 5 by 18. That is 100 by 18. Something will come. That is meter per second. Suppose you want to convert reverse. 1 meter per second is equal to 18 by 5 you can write it. 1 meter per second is equal to 18 by 5 kilometer per hour. Means vice versa, I can convert meter per second into kilometer per hour or kilometer per second into, even in your electrical energy also measured in kilometer per hour only. Or kilowatt hour you can say it as. Right. So that when body is moving with in specific direction, the speed in specific direction is called velocity. That's all. When direction is mentioned, then you can call it as velocity. When direction is not mentioned, we can term it as a speed. So speed can be, this speed can be of any type. Two types you can write mainly. One is uniform speed. Other one is non-uniform speed or velocity, you can say non-uniform velocity, average velocity. Right. Just a minute. So either you are reading about the speed or velocity, you can find one is number one, uniform velocity. Number two, variable, it is also called non-uniform. Non-uniform is also called variable. Right. Third one is average velocity, average speed or average velocity. Right. So when you come to the part, discuss about these terms, which generally we'll use in the kinematics topic. Uniform velocity. What is uniform? If a body covers same distance in same time, means if you go with a constant speed or constant velocity. Suppose you have started from here to here. So some A to B you have to go. So A to B, there is a two destinations. One is 1 kilometer, other is 1 kilo. 2 kilometers are there totally. First, from A to say O, 1 kilometer, you took 5 minutes of time. Second, again, you took the 5 minutes of time. So what is the meaning here? You are going with the same speed or constant speed. Means if a body covers equal distance in equal time. Here time is 5 minutes, distance is 1 kilometer. So both distances covers only in 5 meters only, 5 minutes only. So the body or vehicle is moving with the constant speed, right? You can say. Suppose it's not like that. There is a speed is varying. For the first kilometer, it covers in 5 minutes. Second covered only in 3 minutes. Means increased. Then you can call it as non-uniform or variable speed or variable velocity. Okay. Then average. What is average? We know average very well. Average speed. So total distance by total time. Total distance you have to calculate and total time, because different cases are there. Total time will give the average velocity or average speed. Right. Total distance by total time. Okay. So these are the terms which come across during the study of our about our motion. When a body is in motion, we'll come across distance, displacement, speed, velocity, and next is acceleration and retardation. So all common word only will use regularly. Accelerating. Every vehicle will have accelerator. When you accelerate, speed decreases. When you decrease when you accelerate is down, the speed decrease. Increasing of speed is called acceleration. Decreasing of speed is called retardation or negative acceleration or deacceleration. So you can see on the screen clearly. I think you have not written this one. You can note down. See here. Acceleration. Acceleration is increasing the rate of change of velocity. increasing rate of change of velocity is called acceleration, right? Right? Then deceleration is retardation. Decrease in the rate of change of velocity. Velocity increases, you can call it as acceleration. Velocity decreases from time to time, it's called as deacceleration or retardation. Acceleration is a vector quantity. Retardation also a vector quantity because they have specific direction along with magnitude. Acceleration is positive. Okay. Acceleration is positive and retardation is negative. Formula you can see, change in velocity by time, acceleration. That is rate of change of velocity. That is v minus u by t. A is equal to. Whereas retardation is given by u minus v by t. Why? Because u is more. Started with the more speed and decreases the speed. Final velocity is less than initial velocity. So you can get u minus v by t. Either it is the acceleration or retardation, we measure in the meter per second square or centimeter per second square. So the meter by second square you can write. When second comes in, become meter into s minus 2, what given here. Come to numerator. Centimeter per second square is the unit for both acceleration and retardation. Right? Hope you have written this one on notebook. If not, write down. Take some time and note the points here. 4 points are there, 5 points. First, if you already written the last class, just text me. Good to see many branches. Jogipet KTS, Banur KTS, Gulimarkapur KTS, Ishanba KTS, Wani Block, Oak Ridge International School, Medchal, Ramnagar High School. Somebody with Redmi phone. I don't know who is it. Mastermind Sayat Nagar, Mastermind CCAL. So be regular to the classes so that you can understand the continuity of the subject. And maintain the proper notebook, students, for IIT Foundation. Right? I am moving forward. What happened, Hayat Nagar? Right. Here, very important. I'll explanation I'll give for here. We have seen already in the last class, but need explanation here. So what you can find here? Equations of motion. What? Equations of motion. So see, this is the first equation. Which one is here? First equation of motion is V is equal to U plus AT. Equation 1. Right? Equation of motion, heading you can write. Very important, I'll tell you, I'll tell the derivation for you to note down. Equation of motion. Answer equation is this. How you got this? We got this from the definition of acceleration. What is acceleration? Rate of change of velocity, that is change in velocity. Change in velocity by time. That is V minus U by T. A is equal to. From here, AT is equal to V minus U. Or V is equal to U plus AT. That is equation. What is there here in this? V is equal to, here what? V is equal to final velocity. V is equal to final velocity. Note down all of you, all this. Velocity. U is equal to initial velocity. And A is equal to acceleration. And T is equal to time taken. Right? So, first equation of motion is V is equal to U plus AT, which you obtained from the definition of acceleration. According to the definition of acceleration, change in velocity by time. That is mathematically given by A is equal to V minus U by T. From that we got AT is equal to T, we brought this side. AT is equal to V minus U, or V is equal to U plus AT. Say equation 1. What is this V? V is final velocity, U is initial velocity, A is acceleration, and T is the time taken. Right? Note on this. Very, very important equations they are, which are helpful for you to solve so many problems, to know unknown values. You can find out acceleration, velocity, time, displacement, anything by using these 3 equations of motion. Right? Done, all of you? I'll go for the second equation. Okay. Next one is second equation of motion. Right? So, you can write second equation. Let's write it short form. Okay. What is the equation here? S is equal to ut plus 1 by 2 at square. Very important equation, which gives the formula for distance. S is distance here. How you got this equation? Simple. We know what is the formula for distance? U is equal to velocity into time. Because you know velocity is equal to distance by time. Velocity into time is the formula for S. Correct or not? But what is velocity here? We have 2 velocities here. One is initial velocity, other is final velocity. So you have to take the average velocity. That is average velocity into time. The formula for distance. So what is the average of V and U? V plus U by 2. You know the average, how to find out? You will get for your report card also. 6 subjects, 600 marks. Into time is T. Right? S is equal to average velocity into time. But here what is the twist is, in place of V, we wrote the equation of 1. That is, in place of V, U plus AT I wrote. Plus again U is there as it is, you can keep by 2 into T. In brackets you can write, since V is equal to U plus AT. So in place of V, what we have done? U plus AT I wrote. So what you got now? U plus U is there. That is 2U. 2U plus AT by 2 into T. Next step, come here. So T is there, you can multiply T with both. It becomes 2UT plus AT into T, AT square by 2. S is equal to. This can be done like this. S is equal to 2UT by 2 plus AT square by 2. Separately you can write. So 2 cancel here. Therefore, S is equal to UT plus 1 by 2 AT square. Right. The simple from the definition of distance only we find the complete value and derive the equation. Start from here. S is equal to velocity into time, but there are 2 velocities are there, so we have to take average velocity into time. So in place of V, we substituted the U plus AT from the equation 1. U plus AT substituted here. Then we got 2U plus AT by 2 into T. Again, after opening the brackets, 2UT plus AT square by 2. Again, separately we wrote. So finally, we got S is equal to UT plus half AT square. Right? Note down there. Right. First, start from here. First, and come to second page here. Right? This is second equation of motion. See here, S is equal to distance. U is equal to initial velocity. A is equal to acceleration. T is equal to time. What already we have learned about each and every word term. Right? Hope you are done. So I'm moving to the third equation. Okay. Third equation of motion. What one? Next, third equation. Right? What is the third equation? V square minus U square is equal to 2AS. What? So how you can get this one? Same you can get from the definition of distance is equal to velocity into time. Okay. So distance is equal to velocity into time. Distance is equal to average velocity because there are two velocities are there already. Average because initial velocity and final velocity into time. So you know what is average velocity? U plus V by 2 into what is time? Time you can write from here. See, I'm writing the bracket. V is equal to U plus 8 is there. Na? From here, V minus U by A is equal to T you can write. Means for T formula we are derived here. You want T, take U this side, it becomes V minus U. A comes to denominator. So in place of T, you can write V minus U by A. Okay. So S is equal to V plus U by 2 or V plus U into V minus U by 2A. Multiplication is the 2A denominator, U plus V or V plus U, V minus U. So what is the formula it is? A plus B into A minus B formula. A plus B into A minus B is nothing but A square minus B square by 2A. So 2A take this side. It becomes therefore V square minus U square is equal to 2AS. Or you can write V square is equal to U square plus 2AS, any formula. Simple, from there only. Whatever formulas are there, by using them, we are getting a new formula. By using first one, we got second formula. By using again first one and second one and first one, we are getting the third formula. Here we can find out what is V. V is nothing but final velocity. U is initial velocity. A is acceleration. S is the distance. As per the data given in the formula, you have to select which formula is applicable. Okay? Write down this finally. So after this, we have acceleration due to gravity is there. The influence of gravitational force. How these three equations changes, we can learn. Right. So before closing the session, let me So graphs we'll discuss in next class. What is the graphs and how to understand the motion of a body by seeing the graph. See, a graph is totally curved. So it's a variable speed. How to represent uniform speed, variable speed, rest, motion. Very different types of graphs will explain you the nature of motion. You can say nature of motion. What way body is moving. Okay. All these things maybe between displacement and time, or between velocity and time, or between acceleration and time. You can draw the graph and understand the nature of the motion of a body. Okay. So under the conclusion is very important. Sorry, here graphs not explained today, but just today mention about the homework as write equations of motion. Right? Equations of motion you mention and write it for today. Right? Today's homework is our daily practice problem is equations of motion. Equations of motion. All the three equations you can write in your notebook as a daily practice problem or homework, and take the signatures from your parents and teacher. Right? So that's all for today, students. Thank you very much. Have a wonderful day. See you next week.